Alright, welcome to another pre-calculus concept. First I thought I'd share this with you. My son insists that this is a cheetah. I don't know, I can't win the argument with him, but it's definitely a leopard. If you don't know why, ask. But it is. It's a leopard for sure, not a cheetah. Alright, but what we're talking about today is something I've seen we've all had trouble with, and you can't go through what we're doing in class right now if you don't understand how this works. It's basically giving you a radian measure of an angle and figuring out where it is on the unit circle. So I'm going to give you 3 ways to do this, and we're going to do about 4 example problems, just to look at all the different types of angles. So the first way is to convert to degrees. This will take you the longest. There's just a lot of work to it. It'll work. It's just kind of tedious to do. But to do it, what you're going to do is you're going to take the angle and you're going to multiply it by 180 over pi. That's how you convert radians to degrees. So mathematically, when you do that, you're going to multiply the numerator, 7 pi times 180, and that's going to give you 1,260 pi. And you're going to multiply the denominators, which is a lot easier. It's 3 pi. Alright, and then it's just a matter of dividing those two fractions together. So you do 1260 divided by 3, and that's going to give you 420. And then the pi's divide out, so you get 420 degrees. It still doesn't tell you where you're at. You still have to use some logic to figure out where this goes. So you draw a picture, an XY axis, and we're going to start, there's 0. And what you really need to be aware of is we have 90 degrees, 180 degrees, 270 degrees, 360. And it keeps adding 90. That's one rotation. We can add 90 to this, and this would be 450 degrees. So it keeps going in that manner as long as you have to go. So this can get kind of tedious. But what we're going to do is we're going to start from here, and we're going to just kind of circle our way around. So one full circle, that's 360 degrees. That still didn't take us to 420. So what you're going to want to do in a situation like this is subtract out the circle. When you do that, 420 minus 360, you're going to get 60. So that means after one full circle, we'll travel another 60 degrees. And we'll be looking at an angle that goes right there. Terminal point ends there. Alright, so that's how you do it with degrees. And you could do this in positive or negative. A negative angle would just go in a clockwise direction. Alright, so that's how you convert from radians to degrees. This way is my favorite way. It's fast. It can be a little confusing, but once you get it, it usually goes pretty quickly. I like to use the fact that pi is 180, which is something you should all know by the time you get out of my class. And that's a half circle. And we can use this to count half circles all the way around until we get one section away. Or whatever, one section too many or one section too few. So what I mean by that is this. You're going to focus on that bottom number, and this is pi. Okay, we're doing pi over 3, so essentially we're doing 7 sections of pi over 3. The easiest way to do this and figure this out is to divide this into thirds. Okay, well if that's pi, then I would need a 3 here to create a 3 pi over 3, which is pi. So this is still representing pi, but now we're in units that were useful to us, a third. So all I have to do is start from 0 and go to here. And that is 3 units of 3. I need 7. So I'm going to keep going. Another half circle gives us 3 more. That brings us to 6 total. 3 plus 3 is 6. I need 7. I'm still not there yet. Well, if I go all the way around again, I'm going to get to 9. That's too many. But if I'm at 3 pi over 3, that means, or 6 pi over 3 right now, that's where I'm at, because there's 6 of them, I need 1 more to get to 7 pi over 3. So I'm just going to go 1 more out from here. And that's going to be my last one. So that's another, and if you don't know, pi over 3 is 60 degrees. That's what you should be thinking of right away. So I'm going 1 more 60-degree angle, just like I did up here, and I'm getting to the same location. And that's all there is to it. If we were in fourths, we'd count 4 pi over 4. sixth would be 6 pi over 6, and you can count your way around that, and I'll show some examples later, but this is probably the easiest way I know how, and you don't have to do a lot of work for it. I'll go faster on the next few. Alright, then there's this way. You basically have to label your axes as 0, 90, 180, 270, 360. Instead of those, go in radians. You should know 0, so I like to go here's 0, here's pi. Those are the two easiest ones to set up. This is halfway between them, so it's half a pi or 0.5 pi. Okay, this is pi, this is 2 pi all the way around, full circle. What's halfway between 1 and 2? 1.5, so it's 1.5 pi. Then you take your function, 7 pi over 3, you actually divide out and you get 2.3. And I say right here, this is useful if you really are not good with fractions. It's tedious when you have many, many rotations, but so are all of these. But basically, if you're really bad at fractions, you could change this to a decimal, 2.3, and say, where does 2.3 fall in this range? So 0 to 0.5, no. 0.5 to 1, no. 1 to 1.5, no. 1.5 to 2, still a little bit short, so we'll have to do a little bit more. But you're seeing it just adds 0.5 pi each time, so this is going to be equivalent. So 2, we're going to make it 2.5 pi. And you can keep doing this as you go. This would be 3 pi, 3.5, 4, 4.5, so on and so forth. But 2.3 falls in this range between these two. So without doing too much work, we'll know we're still in the quadrant. So those are the 3 ways I think that would be best suited to figure out where these angles are. All right, and we'll go through those examples again. I have about 4 examples for you guys to really look at and test yourselves with. So we've got a couple more. We'll go a little faster now. So determine where 7 pi over 6 is. Again, the easiest way I know how, 7 pi over 6, treat this as pi. Okay. We are looking at the number 6 in our fraction, so we're looking at segments of pi over 6. There's 7 of them. So what I'm going to do here is say, okay, I'm going to look at units of 6. So to make this equivalent, I need a 6 there. That's 6 units of 6. So starting from 0 and going to here, that's 6 of them. I need 7. If I go 6 more to the other half, that's 12. It's too many. So I'm only going to go 1 more unit. This is 6. 1 more would give me 7. And if you don't know, pi over 6, that's an increment of 30 degrees, which should be automatic at one point that you know. So I'm basically going to go 30 degrees more into this quadrant. There's 6 pi over 6's plus 1 more. We're looking at the third quadrant for our answer. Okay, so that's really quick to do that way. If I were to do it with converting radians to degrees, I'll do that here. Converting radians to degrees, I'll do on the left. We would basically be doing 7 pi over 6 times 180 over pi. And we're going to multiply the numerator. 7 pi times 180, 1260 pi, 6 times pi, 6 pi. And we're going to divide those, and we're going to get 210 degrees. So what we would do on the picture, remember there's 0, there's 90, there's 180, not there yet, 270. So you know 210 is going to be between these. It's going to be down into the third quadrant. How far away from 180 would 210 be? Well, you would just subtract them. 210 minus 180 would be 30. This is a 30-degree angle into that quadrant, just like this was. All right. I'll do the next example kind of like the letter C before. So example 3, I'll do it the quick way that I like. So this was method B from before. The quick way is just drawing your unit circle. Here's pi. Segment it off into fourths because of the 4 here. So we're going to go 4 pi over 4, and we're going to go half circles until we get really close to 3. This is negative, so we're going to actually rotate in the opposite direction. So it's going to look like that. That is 4 of them. We only needed 3, so we went a little bit too far. So what we're going to do, and by way of fourth is 45-degree angle, we went 1 too far. Because we went 4, we wanted to go 3. So you're going to cut 1 off, and we're actually going to stop it right here. So the angle is actually going to be that section. We're not actually going all the way there, but this is where it's going to end up in the third quadrant. Alrighty, and the other way I said is we could go ahead and, 0, 0.5 pi, 1 pi, 1.5 pi. Alright, and we could go ahead and look negative 3/4 is equivalent to negative 0.75 pi. I made a little bit of a goof when I wrote this. Realistically, since we're going negative, we're traveling in this direction, so this would actually be negative 0.5 pi. This would be negative 1.5 pi. We'd be going backwards. So where would negative 0.75 fall? It would fall in this quadrant right here, and we're going to get the same answer. So that's another way to do it. Alright, and I'll do one more. Negative 25 pi over 6. Alright, so we're going to go a little quicker. Letter B. This is my favorite way, so I do it on every one. Sorry. If you don't like it, you have 3 options to do. Negative 25 pi over 6, you are looking at the number 6. That should automatically tell you we're looking at 30-degree increments here. There's 25 of them, so it's going to take a while. And we are going to label this as pi, always, and we're going to split it up into 6. So there should be 6 pieces of 6 to make pi. Alright, and we're just going to kind of count. I'm going to start small because I'm going to be doing multiple rotations. There are 6 of them. That's 6 more, so we're up. So we're at 6 here, plus 6 more is 12. We're at 12 right now. We need to get to the 25, so we keep going. 6 more is 18. Not there yet. 6 more. We're up to 24 right now, so this is 24. We need 25, so we're going to go one more. Not all the way around, but just one more 30-degree angle. So we're going to end up into that quadrant right there. So we end up in the 4th quadrant. That's how you do it. And again, if you went and did this with conversions, you're going to do negative 25 pi over 6 times 180 over pi. And as you can see, these are going to be some very, very big numbers. We're going to actually get negative 4,500 pi over 6 pi, which comes out to be let's see here, 750 degrees. It's not terrible, negative 750 degrees. So basically we have to figure out how many rotations that is. So if we're going negative 1 full rotation, we're taking away 360 degrees. So we're going to add a 360 degrees, and that's going to give us 390. Alright. So then we're going to do it again. We can actually get another 360 degree rotation in there, so we're going to continue. There's another one, so we're going to add another 360, and that's going to bring us to negative 30 degrees. Alright, so we're going to end up right about, actually I was going a little backwards there, so I should be doing clockwise rotation, so it should be 360, 360, and then 30 more into this quadrant. So we end up in the same location as before. Those are the different ways to do it. You pick the one that works for you. Again, if you can get this down, it's probably the easiest and fastest way to do it. This will work. It's just, there's more work to do there. But whatever works for you, good luck. And remember, most importantly, that's a leopard.